Here we are. We've set up our spreadsheet according to what the lab handout says, but we've got some issues, right, because these are running into each other. So click on the B up here all the way at the top. Click and drag over so that you highlight C as well, and you see that when you click the top here, you get the entire column highlighted. Hover with your mouse over the line between B and C, then double-click when you see that 2-arrow icon. When you double-click, it'll auto-adjust the width to fit the text. Next, we have to do some superscripts, so you can double-click to enter the cell, or you can just click up here in the formula bar, highlight the 6 there, and then to superscript, you can click on Home, then click this arrow within the font box. But it's actually way quicker. Instead of doing that, just do Shift and Control on your keyboard, and while holding those down, hit the F button as well. That stands for font. Check the box for superscript, then hit Enter on your keyboard. Then hit Enter again to save your work in the formula bar. Next, I come over to here, I highlight the 3, Shift Control F, superscript and Enter. Highlight the 3 again, Shift Control F, superscript, Enter, and then I go here, Shift Control F, superscript, Enter, and last one. Now, when we're formatting, variables like R are typically italicized. So double-click, highlight the variable, and then on your keyboard, hold Control and hit I at the same time. Hit Enter, of course, or Tab to save your work in the formula bar. Don't italicize units, just the variables. All right. Next, I'm going to click on the A to highlight the entire column. I'll go all the way across, click and drag, and then I'm going to put these in the middle of the cell. So click on Home, then under Alignment, there's a bottom row here for center alignment. Horizontally centered. Okay, good to go. Now we need data from NASA. There's a planetary fact sheet. You can find it by doing a Google search for NASA planetary fact sheet, and it's the first hit. We need to know the distance from the sun. How far are these suckers? So click with your mouse, click and drag all the way across. Then on your keyboard, hold Control and hit C for copy. Control C to copy. I'm going to paste it down here. That's Control V. What's that star? Hey, wait a second, that's the moon. If you go back and look, the 4th column is the moon. How'd that sneak in there? That's not a planet. It's not orbiting the sun. So let's take that out. I'm gonna hit Delete on my keyboard. Okay, those are the distances. Those are the values of R. They will go here. We just have to move them. Now let's get the period for each planet. Let's see, orbital period, there it is. So I click with my mouse, I hold down, I drag across. Once they're all highlighted, with my keyboard, hold Control and hit C. Control C is copy, Control V is paste. And I delete the moon, just from this experiment. Next part is a little tedious. You click here. Well, we gotta move these to here. So click, and then Control X is cut. Click, Control V is paste. Control X, Control V. Control X, Control V. My computer is running a little slow, but you can see how quick this really is. The quick click, quick click. Do that 5 times fast. Quick click, quick click, quick click. What can I say right now? I heard a good joke the other day. A bear walks into a restaurant, and the waiter comes over and says, "Hi, what can I get you?" And the bear says, "I'd like a coffee and a piece of toast." And the waiter says, "Why the big paws?" Get it? The bear has large paws. Here's another one. What do you call a dog with no legs? Doesn't matter what you call him, he ain't coming. Okay, moving on. Next, we have to calculate these values here are in kilometers, and this is not 57 kilometers, it's 57 million kilometers. So we have to convert this value into meters. I will give you this conversion. We have to, let me zoom in. Okay, you hit equals because every time you do a formula in Excel, you have to indicate this by hitting equals first. Don't type 57.9 and then do your math. Instead, we click the cell that contains the value we want to multiply. Now we have to multiply it by 1,000,000. That's 10 to the 6. We're putting that back into the value itself. It's no longer part of the units. Also, we have to take this kilometers and put it back in the value itself. Kilo is equal to 10 to the 3. Then you hit enter on your keyboard. Okay, now we have to copy this formula into the cells below. The quick way to do this with your mouse is you click on the cell, find that green box in the corner, that's the copy and paste box. If you click on that and you drag it down, you'll copy and paste the formula to everything below. Now, enter a formula, so hit equals, to calculate the orbital periods. Click on the 88. It's right now in days. We need to convert that to seconds. I don't want to show you how to do this, so I'll just do something that's wrong. There's my formula, not quite right, and then I hit enter on my keyboard. Okay, again, you can drag this down. Now, instead of doing it this way, if you want, you can hold Control-C, highlight with your mouse. Notice here when I highlighted just now, I didn't click this box in the corner. I clicked right in the middle of the cell. That's the select tool. Now I want to paste this to the cells below, so I hold Control and I hit V to paste. Then we have to hit equals, click here, raise this to the power of 3, hit enter, and likewise you will be squaring these values. Okay, now it's time to enter our, to create our graph. Now if you highlight these and do insert, choose the scatter plot option, your data is going to be backwards. It's going to automatically put r cubed on the x-axis. We want it on the y-axis. So to avoid that, what I recommend is click away off of the data. I've got an empty cell selected. Click on Insert. Can you see Insert? Then choose the scatter plot option, and from those that are shown, choose the first option with no connecting line. Okay, then we right-click and we click on Select Data. It's about halfway down. We add a new series. This is an XY series. Click into X values and highlight what's on the X-axis, t². Highlight this with your mouse, click and drag, the equals 1, delete that, and then find your Y values from your graph, from your data table. It's these. Click and drag all the way to the bottom. Then hit OK. Click OK once more, and there we go. Now you want to put this down below. You can give it a chart title. You'll need axis titles, so click the plus. Check the box for axis titles right there. Go ahead and check the box for trend line. And then you can click on the arrow and do more options. Check this box here for display our equation. And because this is fun, show the r² value. The r² value is kind of an indication of how straight the line is. Whoa! Ho-ho! The perfect number is 1. That's the best it gets. And it kind of is an indication of how straight your line is. Not totally, that's not completely accurate. But for, if the line looks straight already, then you could sort of trust this as an indication of how straight. All right, something goes here. I'll give you this, and you have to do the x-axis. Just like before, you can hold Shift, Control, and F, Superscript, And there's actually a shortcut. When you're inside of the graph, you can do Shift-Control+ to raise it to the exponent. And finally, I will italicize the R. Something goes here on your x-axis. Now here's the problem. When you look at this graph, you don't have much detail. See that? 7 times 10 to the 24? Well, what's the next decimal place? Excel won't tell us when we look at our graph. So instead, come over into an empty cell, type slope. Then, beside it, hit equals. We're going to do a formula to calculate the slope. Equals slope, open parentheses. Click and highlight your y values. Hit comma, click and highlight your x-axis values. So it's backwards, we're doing y's first. Close the parentheses and hit enter. Okay. Now we've got the slope. We're going to calculate next mass of Earth. No. Mass of Sun. So to do this, we will have to think about that equation we derived, right? What was that equation? Slope equals, I'm going to write something that's wrong, 2, pi over g, m or something. Where's m? How about 2m, 2 pi m? I'm not sure. And so you have to isolate mass. Okay, 2 times slope, g over pi. This is wrong, don't follow this. I'm just giving you an example. I don't want to show you the correct answer. I want you to figure that out. And then you would hit equals, and you would follow your formula. So you would do 2 times, so star for times, that's Shift 8 for the star. Click on slope, times pi. You can do 3.1415925. Or if you want, you can just type pi, and then open parentheses, close parentheses. That's how you get pi. But I'm supposed to be dividing by pi in my wrong equation here, and then I would have to multiply by g. 6.67 times 10 to the minus 11. Okay, clearly that's wrong. Clearly there are some things off here, but that's how you will calculate the mass of the sun. Okay, thanks for watching. Oh, there's one last thing. Percent error. You'll have to go look up the actual mass of the sun, and let's say it's 15. You would do experimental value minus the actual value, the theoretical correct amount, over the actual value. And you click on the cell, click home, change this to a percent under the number tab. Change it to a percent. That is a lousy percent. Good thing this is not the correct way to go about it. You should get something of like around 0.3%, if I recall correctly. So this is how you do the Kepler's Law Lab. Thanks for watching. You can turn in at the end when you finish, turn in your Excel file.